The KATRIN experiment cuts the mass estimate for the elusive neutrino in half. At the 2019 Topics in Astroparticle and Underground Physics Conference in Toyama, Japan, leaders from the KATRIN experiment reported on September 13th that the estimated range for the rest mass of the neutrino is no larger than about 1 electron volt. These results, obtained from the KATRIN experiment, lowered the upper limit of a neutrino's mass from 2 electron volts to 1 electron volt. Knowing the mass of the neutrino will allow scientists to answer fundamental questions in cosmology, astrophysics, and particle physics, such as how the universe evolved or what physics exists beyond the Standard Model, said Professor Emeritus Hamish Robertson. These findings by the KATRIN collaboration reduce the previous mass range for the neutrino by a factor of 2, place more stringent criteria on what the neutrino's mass actually is, and provide a path forward to measure its value definitively. Neutrinos are abundant. They are one of the most common fundamental particles in our universe, second only to photons. Yet neutrinos are elusive. They are neutral particles with no charge, and they interact with other matter only through the aptly named weak interaction. If you fill the solar system with lead out to 50 times beyond the orbit of Pluto, about half of the neutrinos emitted by the sun would still leave the solar system without interacting with that lead, said Robertson. KATRIN scientists cannot directly measure neutrinos, but they can measure electrons and try to calculate neutrino properties based on electron properties. These efforts may also reveal the existence of sterile neutrinos, a possible candidate for the dark matter that, though accounting for 85% of matter in the universe, remains undetected. Neutrinos are strange little particles, said Peter Doe, UW physics professor. They're so ubiquitous, and there's so much we can learn once we determine this value. Stay connected with our department. Follow us on Instagram at UW-Physics, Twitter at PhysicsUW, Facebook at University of Washington Department of Physics, Vimeo, LinkedIn, and Pinterest at University of Washington Physics. Subscribe to our channel for more physics updates.